Today, you finally finished building your API. Hey guys, the API is ready. You can start using it now. What's the endpoint
What
URL?
parameters do I need to pass?
What does this response
Why am I
mean?
getting 400?
This is exactly why we need API documentation. Without documentation, your API is like a machine with no manual. It works, but nobody knows how to use it properly. Think about when we use the Stripe API. Before writing a single line of integration code, what do? We open their API documentation. From there, we can clearly see the exact endpoint URL, the HTTP method, is it GET or POST, what parameters are required, the request format, the response structure, and possible error responses. Once we understand the response structure, we know exactly what to do next. Save any response data into our database, trigger another action, update the UI, or handle errors properly. No guessing, no message spam. So, how is API documentation actually built? Do we open a file and manually type every single endpoint parameters and response models? Imagine if the API has 100 endpoints, you'll cry and quit the job. And the worst part? Every time you change one property in your model, you must remember to update the documentation manually. Miss one small detail? Outdated documentation. But don't worry, here comes the hero. OpenAPI. OpenAPI specification is like a standardized blueprint for your API. Instead of writing documentation manually, your API describes itself in this JSON structured format. Endpoints, parameters, responses, status codes, all written in a machine-readable document. And this OpenAPI document can be auto-generated. Let's see how. By the way, for this demo, I'm opening my existing e-commerce web app project. If you're interested in this full project, you can find the link in the description below. To generate the OpenAPI document, first, install this NuGet package. Now open program.cs. Add this. This tells .NET. Scan my controllers, minimal API endpoints, route attributes, request models, response types, and generate an OpenAPI document based on my code. Then add app.map.OpenAPI. This exposes the generated OpenAPI document as a JSON endpoint. Right now, this is just a web app project. It doesn't even have an API endpoint yet. So let's quickly add one simple FAQ endpoint for this demo. Now run the project. Append this to the URL /OpenAPI/v1.json. You'll see the OpenAPI document automatically generated. The FAQ endpoint, its parameter, its response, status codes, all extracted from the code. Now, technically your client can read this, but it's JSON. Not very friendly, right? So we have one more step. We're going to turn this machine-readable JSON into a beautiful, interactive API documentation UI. Tools like Scalar read the OpenAPI document and automatically generate a modern API documentation UI. Let's set it up. Install this NuGet package. Then add this using statement. And in program.cs, add app.map Scalar API reference. That's it. Now run the project. Append /Scalar. Nice! The FAQ endpoint appears automatically. Parameter, response, everything. If you add more endpoints, they'll automatically appear here too. You can switch to dark mode by clicking this button, or even force dark mode at startup. By default, the browser tab title shows Scalar API reference. Let's change it to Premerse API reference. Now, I want a custom title and a description section just like the Stripe API reference. To do that, we update the OpenAPI configuration inside Add OpenAPI. Specify title, version, description. Now refresh. The OpenAPI document updates. And Scalar updates automatically too. Beautiful. Now another cool trick. This field is internal only and we don't want it showing up in the API document. We can hide it using JSON ignore attribute. That field disappears from the OpenAPI specification, and Scalar hides it too. But plot twist. Hiding a field in the API documentation does not remove it from backend. The field still exists. So if someone sends that hidden field manually, and your backend blindly maps everything, a security incident happens. For example, the API document doesn't show is admin field, but an attacker sends is admin equals to true. If the backend auto-maps all inputs without validation, we just gave them the admin powers. Moral of the story: hiding fields is great for clean API documentation, but never trust the client. Always validate what fields can be updated at backend. Now, let's make the API documentation even more helpful. We can add summary descriptions to the endpoints, request models, even individual fields. But there's a catch. By default, the API document don't know these comments exist. So we flip one tiny switch in the project settings. Tell the compiler to generate an XML documentation file. Now when the project builds, all those summary comments get exported into an XML file, and Scalar can read them and display them in the API documentation. Now, our endpoints explain themselves in the document. The fields have helpful hints, and client stops guessing what the API does. Next trick: hiding endpoints. Sometimes we don't want certain endpoints showing up in public API documentation, like admin tools or internal endpoints. We can hide them from the API document. For controller actions, use API Explorer settings, ignore API equals true. For minimal API, use exclude from description. Now they disappear from the documentation. But same warning, hiding is not securing. The endpoint is still alive. It's just invisible from the API document. If someone knows the URL, they can still call it. So for real protection, don't just hide admin endpoints. Use proper authorization so that only admins can access admin endpoints. Now, I want the default programming language to be C#. This is not OpenAPI related, it's Scalar configuration. So, modify the map Scalar API reference part, add. With default HTTP client, Scalar target C#. Now, I want a button that redirects back to my e-commerce homepage. We can inject custom HTML using header content, which renders after body tag, and add custom CSS class in head content, which renders inside head tag to style the button. Now, we have a beautiful back to home button. Click it, back to e-commerce homepage. Now, did you notice there are many language options? If you only want a few, you can explicitly configure enable clients. Clean and controlled. Now look at this button, test request. Yes, we can test the API directly inside the documentation. Super nice. Let me copy a real FAQ ID from my e-commerce system. Paste the ID. Yes, correct FAQ return. Now let me try a random ID that doesn't exist. I get not found error. Now we know the endpoint works. The response is correct. The error handling works. Your client can immediately see expected behavior, and they can display the Q&A on their website, save it to their database, or trigger other actions. Scalar has many more customization options. I'll link the documentation in the description below. We can even configure authentication and authorization. Maybe I'll make another video about that in the future. Now, let's try Swaggered. Install NuGet package Swashbuckle.AspNetCore. Let's comment out the OpenAPI and Scalar code. Add this line. Then, app uSwagger. App uSwagger UI. Run the project. Append/Swagger. This is how Swagger UI looks like. You can also test endpoints here. In terms of UI, personally, I think Scalar looks more modern. But what do you think? Do you prefer Swagger or Scalar? Let me know in the comments. And that's how we build API documentation in ASP.NET. From auto-generated OpenAPI to interactive documentation to live endpoint testing. I hope this helps. If you want to see the full e-commerce demo project, you can check it out here, and I'll see you there.